All right, so welcome. This is the first part of the lecture for Chapter 13, which deals with density and buoyancy and why things are heavy feeling or why they float or sink. So before we really jump into the material, there's a couple of vocabulary words that you need to know. Um, Typically in life when we talk about fluids, we usually think of only liquids. However, in physics and chemistry, a fluid is anything that flows, and so this can be gases and liquids because they fill the shape of their container, and they are able to move freely when not contained. And this also contains colloids, and a colloid is something like toothpaste or Play-Doh, gel, things that have both properties of solids and liquids, but they still have the ability to flow. And so a colloid is technically a mixture. And a mixture is technically a liquid, so we're going to go with that. And then density is another one that you're going to need to know. We'll talk about this in detail a little bit more coming up. But it's how much stuff is in stuff. And the formula that we use to talk about density is an object's mass divided by its volume. And so obviously the greater the volume and the less the mass, then the less dense that object is. A great example is something like air. If something has a very large mass and a very small volume, like a block of lead, then it has a high density. When we talk about that, the SI unit for density is kilograms per meter cubed. The next one that we need to know is pressure. Again, this is a word that you use in your daily life in a lot of ways, and it's just the force over a given area. Force is the same that we've always used. It's newtons. Area is going to depend on the shape of that object, where it is in contact with something else. Fluids are able to exert pressure much like stacking books on somebody laying down, and so we now know that air and water are fluids, and just like we are standing on the surface of the earth, we experience a greater pressure when we have more fluid above us, that is more atmosphere. And so the closer that we are to sea level, the more pressure we experience. If we go up somewhere high, like on a mountain, we have less atmosphere above us, and thus we experience less pressure. You have probably seen this when things get shipped across the country from places close to sea level and they come to Colorado and they're all puffed up. That is because of the decrease in pressure. And so you've got a contained system, like a chip bag, or a bottle of shampoo, right? And then when you bring it up to these higher altitudes, it experiences lower pressure and expands because of that. Buoyancy. You may have heard this word before, but we're going to talk about it in really general terms as the ability of something to float or sink. And I've got those in quotations because floating and sinking are relative terms. So something that is more dense than the fluid that it is in. And typically we talk about water, but not always. So if something is more dense than the fluid that it is in, then it will sink. If it is less dense than the fluid that it is in, it will float. And so what we see is in fresh water and salt water, people have different abilities to float because each of those have a different density. And we'll talk about that more a little bit later. Buoyancy is a fun thing. I enjoy that topic. And then, last but not least, viscosity. You may have heard this in terms of talking about things like motor oil, but you can think of viscosity as like the thickness of a fluid, right? And so a good example of this is that like a milkshake or motor oil have a high viscosity, while water itself has a low viscosity. It's not very thick, it flows readily, whereas a milkshake and things like that are a little bit more thick and flow more slowly. Alright, so the first thing that we're going to start out today with is density. And I already talked to you about mass density is equal to its mass, the object's mass in kilograms divided by meters cubed. You're going to need to pay special attentions to these units. This is the SI unit, kilograms per meter cubed. However, oftentimes densities are given in units of grams per centimeter cubed because it's more appropriate for that object. Just be aware that if you are given something in grams per centimeter cubed, you're going to have to convert that to the SI unit to have a correct answer. And so the conversion for that is that 1 gram per centimeter cubed is equal to 1,000 kilograms per meter cubed. And that's a pretty simple conversion. I do want you to go ahead and take a look at table 13.1 on page 406 in your book. This has the densities of a lot of common substances, and so in there you see things like glycerin and seawater and gasoline, and all of those things relative to each other. The first thing that I want you to do is to look at the densities of helium and air. And I want you to think about, okay, well, in terms of density, why does a helium balloon float in air? And so the reason that a helium balloon floats in air is because helium itself is less dense than air, right? And remember that if something has a density less than the fluid that it is in, and air is a fluid, then it will float. And so the density of helium is less than the density of air, the fluid that it is in. So that means helium rises to the top. We do see in balloons after a while that helium actually diffuses out and escapes from that balloon, and air is able to get in. And so after helium balloons have been out for a while, their density changes because the mixture of gases inside that changes. We can see when a helium balloon is at equilibrium, or if it's neutrally buoyant in air, it's just kind of hovering there. And then after a little bit longer, it becomes more dense than air and it sinks down to the floor. All right. The second thing I want you to consider looking at that book is if I were to pour the following liquids into like a graduated cylinder and they're not able to mix, they just sort by density. Which ones would end up on top and which ones would end up on bottom? And so if I were to pour glycerin, seawater, gasoline, mercury, and oil into a graduated cylinder, list those in order that they would occur from the top of that cylinder to the bottom of that cylinder. Alright, and so if you're looking at that table, you are realizing that they are listing things from the least dense to the most dense. And so what I see is that my gasoline is going to be on top. Okay, and so gasoline is going to be the first one. Right? After gasoline, let's see. After gasoline, I've got water, plain old water, but I didn't list that here. Next, I've got seawater, and so seawater is going to be the second one, right? It's the next most dense after gasoline. And then I get glycerin, right? Will be my third one, and mercury will be my last one. Oh, and I forgot oil, okay? Sorry about that. Oil is going to fall between gasoline and seawater, and so oil is actually going to be number 2, seawater number 3, glycerin number 4, and mercury number 5. Right, and that's just from least dense will be the one that floats on the top to most dense. Mercury is going to settle out at the bottom of that column. Okay. And then I want you to consider this last table, or this last question while looking at that table, and that is, why can I, right, and I as a person, float more readily or easily in seawater, but I can't float in fresh water at all, right? And so it is easier for me to float in the ocean than it is to float in a pool, and you've probably experienced this as well if you've ever been to the ocean. Right, and so when I look, I've got the density of seawater is equal to 1,030 kilograms per meter cubed, right? And then fresh water, just plain old water, is equal to 1,000 kilograms per meter cubed. Right? And so the first thing that I need to notice is that the densities of these two are different. Seawater has a greater density, and you can think about it as density is the stuff in stuff, right? Seawater, quite frankly, just has more stuff in it. It's got salt and it's got ions of all kinds of things that lead to that being more dense. And so the reason for a person being able to float easier in seawater than in freshwater is because a person's density, right, might fall somewhere between here. And so I could see that a person could have a density of, let's say, 12, just above 1,000, right? And so like 1,000 and we'll say, let's say 1,020, right? And so if I have a density of 1,020 kilograms per meter cubed, then I am more dense than just fresh water, and so I'm going to sink. However, I am less dense than seawater, and so I'm going to float. A great example of this is the Dead Sea, which a lot of people access through the Israel sign. The Dead Sea is a very, very salty sea, and it's got a density of 1,236 kilograms per meter cubed, which is a huge density, and you can see that the person in this picture is floating well above normal floating levels, and that's because she is much less dense than that seawater. Our Great Salt Lake here over by Old Rangeley actually has a density of 1,236 kilograms per meter cubed. Oftentimes it is referred to as the Dead Sea in the United States. Alright, so density of a human. The average adult, right, and we all have different body compositions, has a density somewhere around 990 kilograms per meter cubed. So what physical attribute would make somebody more likely to float in water? Okay, right? Like if I could change something about someone's body, what would make them more likely to float? And what would make them more likely to sink? Right? And so if I am a person and I have a greater fat content, or if I increase my fat content, then that is going to make me more likely to float because I am more buoyant. Fat is less dense than muscle, right? Likewise, if I increase my muscle content, then I am more likely to sink because muscle is more dense than fat. It takes up less volume and it has more mass per volume than fat. And so then the other kind of interesting question to consider is that what can somebody do to increase or decrease their density while they're trying to float? So if they're not changing their fat content or their muscle content, what can they do that does help control their density while they're trying to float? Right. And so humans have these really great devices inside of us, right? They're able to inflate and deflate, and if you've guessed it already, then great job. But a person can inflate and deflate their lungs, which actually changes their density. And so if you take a big, big breath, then you are more likely to float because you have decreased your density. And if you exhale all of your air, then you're more likely to sink because at that point you have decreased your density. And so what I want you to do is try numbers 1, 3, and 5 in your book. In the next video, I'm going to go through these examples, and you're able to work along with me. And so after you try them, if you didn't get them right, or if you're just totally boggled by them, feel free to go on to the next video and work along with me.